Good morning. I think we'll make a start. I think most of you know me. I'm Kadambot Siddiq. I'm the director of the UWA Institute of Agriculture. And it's great to see people from outside the university. So that shows, Richard, interest in your talk. The first thing is, I must acknowledge that the University of Western Australia is situated on Noongar land, and the Noongar people remain the spiritual and cultural custodians of their land and continue to practice their values, languages, beliefs, and knowledge. So on behalf of the University of Western Australia and Institute of Agriculture, I warmly welcome to you this special lecture delivered by Dr. Richard Smith. A little bit of a brief bio. Richard Smith has degrees in agricultural science and economics from London and Oxford. So this is really a good combination. At the age of 23, he migrated to Western Australia, the best place in the world, as a farm management consultant to 35 farmers. You know, that's really an early days the farm consultancy has started, because all the extension used to be with the State Department of Agriculture, and that too consulting 35 farmers. Managing over 1 million acres, so half of that is hectares. An Australian Wool Board scholarship led to a PhD at the University of Western Australia on sheep grazing systems. Then a CSIRO postdoctoral fellowship on systems theory and modeling at the University of California, Davis. He taught grazing system at the University New England, Armidale. That's when I first started following your publications and so on, particularly on radiation use efficiency and the work you did with, this is not in the notes, that's the work you, that's the work you did with supervised Wal Anderson, the famous Wal Anderson, he's not here today, on sunflower. Remember those wonderful papers in field crop research. And then you joined the CSIRO as a research leader for irrigation. I was following your work there as well. A research associateship at the NASA Goddard Space Flight Center on Earth observations from space enabled a move back to Western Australia in 1990 to develop applications to improve management of Western Australia's renewable resources with over 66 peer-reviewed scientific publications and 52 conference presentations you have. So this is when a lot of people started going to NASA, including famous J.L. Monteith, Professor Monteith. And he went there and worked with NASA in relation to how we can use space technology in agriculture. That is the beginning of that. Of course, we have moved on further. On semi-retirement, I would not say you retired yet, 2009, Richard helped found a not-for-profit for indigenous people in Northwest Kimberley, not many people knew that, and West Papuans in Indonesia. He's also a volunteer guide on the Rottnest Island. So then Richard published a book. We launched that in one of the morning tea at the Institute Morning Tea. So in the lecture today, Richard is going to explore eyes in the sky, satellite remote sensing within agriculture and rangeland. Please welcome Richard.
Thank you very much for the invitation, and given that it's 16 years since I was actively involved in the field of satellite remote sensing, but you will put me straight. Anyway, yes, the book we published. Oh, here it is. Yes. Now, the reason why the book was published was that Department of Lands and Surveys, that becomes Landgate, published its official history in 2016, and it really dealt with, and it says, managing 1 million square miles, this is West Australia, and mapping it in 3 dimensions. And we said, but there's a 4th dimension that they hadn't considered, and the 4th dimension is change. And essentially the technology they had then to measure change didn't exist, or it was just arriving on the scene. And so we wrote our book, and we called it Eyes in the Sky for satellites, because essentially they're a substitute. Here, my eyes, I can just see a finite part of the world with a finite part of the electromagnetic spectrum. And so it's really the ability to view the whole Earth, to measure and to manage the human impacts. And of course, included in that are agriculture and rangeland systems. And we'll be covering that. So, but backtracking a bit, in 1965, I was finishing my diploma in agricultural economics at Oxford University and thinking, what do I do next? And I picked up the Farmers Weekly, and I was reading the Farmers Weekly, and I read about this initiative in Western Australia, pioneered by Henry Houghton, these farm management consultants. And so I write off a letter saying, yes, I was only 23, and I have no experience. I don't know anything about Mediterranean agriculture. And a week later, I got a telegram, came back, you've been appointed farm management consultant. I thought, my God, what? Are they mad? But anyway, when I'd finally settled down and yes, I turned up. And, but I'd say I spent 2 years as a farm consultant, and it was 1 million acres a year of land was being cleared, and as a consultant, I had to write financial plans to raise capital so they could push down more bush. And so I concluded that economics is the dismal science. Apologies to any economist here. But I concluded then that from an ecological point of view, the GDP that we worship is from an ecological point of view is the gross destruction product. It's the measure of the rate at which we destroy the earth. And fortunately, talking to CSIRO and with the support of Professor Wally Stern, I got a Weed Board scholarship and was therefore able to, and CSIRO provided me a Baker's Hill, an experiment, and so I did this early growth of annual pasture, this time of year. The annual pastures are establishing, they're seeking to establish, the sheep are seeking to get a bite. And so, a complex system. I suddenly entered into this world of systems theory, which again was arriving on the scene. And so the reason for a systems modeling is that systems are greater than the sum of their parts. The basis of most research is what we call a reductionist specialist. Yes, in this building, they specialize in molecular biology, and there's a saying, and you were going to get me the quote. Did you find it?
Yeah, I think in general it's from Socrates. The more I learn, the more I realize I know nothing.
Yeah, that's right. Yes. Well, there's a saying in reductionist research, you know more and more about less and less until you know everything about nothing. And so systems are greater than the sum of their parts. And building models of such systems enables you to be able to manage better the outcomes of these complex systems, because they all behave in systems that we don't anticipate. And it took me some time, having got to stage 2, to realize that the problem with solving these models and applying them over large areas, you had to encounter spatial variability, which you do in your fertilizer business, and therefore the ability to measure that spatial variability became important. And then there's solutions, because as you model these systems, you have to solve sets of simultaneous nonlinear differential equations. That was not possible until the advent of computers. So with the advent of computers, we could begin to solve and simulate these systems. Now, the best way to understand the whole process is really every night, most of us watch the weather forecast on the ABC. You see the satellite imagery and so on. Now, those forecasts are coming from what is called a general circulation model. There are 40 of these models around the world, and but the Bureau have their own, CSIRO has one. And, but to solve that model, every day, the initial conditions have to be updated, and that's where the satellite comes in, because these satellites are measuring the Earth and providing the initial conditions. And so, in fact, the first use of satellites was in fact for weather in the 1960s, just looking at cloud, and then of course they became more sophisticated, as we'll discover. But it really, observing the Earth itself is an outcome of the landing of the moon, on the moon in December 1968. And one of the astronauts who was selected, when asked why on earth should he be selected and why should we go to the moon, and he made this comment: it will enlighten the human race and help us all to comprehend that we are an important part of a much bigger universe than we can normally see from the front porch. We actually see very little of the world, and so when we come to remote sensing, our eyes can only see 1% of the electromagnetic spectrum. This is the spectrum, light that's being reflected from the Earth, from solar irradiance, but also being emitted. And so we only see that little bit, but from these satellite sensors you can see much greater part of that spectrum. Well, and I should say, going further out, we get into microwaves, what we call radar satellites, and we'll come to that right at the end. And so the first set of sensors, satellite goes up, they're called Landsat, and they have a set of what we call spectral bands. These bands, where they receive the data, are in what's called the atmospheric windows, where the wavelength is transmitted. And this is Landsat, early one. We're at Landsat 9. This is the original Landsat. And so you can see there's some visible bands. There's the near infrared. And you can see band 3 is red. This is the principal wavelength that's absorbed for photosynthesis. That's why when we look at the vegetation, it's green. It's reflecting the green, but it's absorbing strongly in the red, and it's highly reflective in what we call the near infrared. If the plants absorbed all the incoming irradiance, they couldn't survive. They would overheat. So they only use half the incoming, and they also evaporate water. And yes, and for that we calculate, and one of the most useful measures is what we call the normalized difference vegetation index, and we'll come to it. And okay, and these sensors are put on two types of satellites. We get what are called the geostationary, that sit up above the equator, and as the Earth rotates, they rotate with it. And as we sit here at this moment, what is changing rapidly? Pardon?
Where we are in the universe.
You're right. We are moving at 1,000 kilometers an hour. But can you feel it? No. But anyway, and of course we get the polar orbiting satellites, which in fact are much closer to Earth, and yeah, this is where we're getting our weather from Himawari 8. I think it might be Himawari. It's a Japanese satellite. Himawari means sunflower in Japanese, and it's sitting up at that. And now this is coming from another satellite over the Pacific, but it shows you how it's continuously scanning that part of the Earth, and so it can pick up an instantaneous events like this volcano. Yeah. Now, in 1979, with Landsat data becoming available, and President Reagan decided it should be privatized, and so the data was expensive. We in the state had begun to have a look and say, well, we wanted to use this data, but the only people who could afford it was the mining industry. So the federal government puts up this dish in Alice Springs to receive the data coming from the Landsat system. The mining industry could afford it. State government, we set up their own unit called RSAC, Remote Sensing Application Center. And as the mining industry, and of course our own geologic survey, would buy the satellite imagery, we would then on-sell it and use it for renewable resources. Now, I was contracted from CSIRO to help the state government introduce this technology, and I was told explicitly, you have to work on renewable resources. And of course, in time, CSIRO said, no, the money's in mining. You've got to work on mine site rehabilitation. And I said, I'm not interested in mine site rehabilitation. I want to look at the big picture. So I left CSIRO and joined the state government, and which was actually marvelous, because I suddenly found instead of having only one research assistant, I now had 10 of them. So I could have the ideas, and I had plenty of people to go away and do the data. So yeah, Landsat. Whole series, Landsat 9, and we're waiting for the next one. So it's a continuous data set, absolutely. So if you want to look at what's been happening on a place on the globe, you can go all the way from 72 through to the present, and you can look at what's been happening, the human impact. And of course, it's global data, but the satellite only repeats every 16 days. It comes back to the same place. It has 30-meter spatial resolution on the ground, and but it's a data set, and it's free now, absolutely free. Pull it from the cloud, but you have to train your students to be able to do it, as I've discovered. And okay, now what we discovered, and in fact it was a student who studied spectroscopy here and an engineer at Curtin University. We couldn't afford Landsat data, it was too expensive. But the meteorological data that the Bureau was using was free. It was free to ground, because we were signatory to the World Meteorological Agreement, and so we got free ground. All you had to do was to put your dish up. And so this is the first dish at Curtin University. They got an old Bofors gun mount, put a dish on it, and then the only other problem was, as the satellite came, you had to pick up the signal and had to track it, because you're tracking this satellite as it's going over at 30,000 kilometers an hour. And so you had to have an oscilloscope. And of course, the time, satellites go over during the day, but also at nighttime. The biggest problem was to get students at nighttime to go and read the oscilloscope. But then they bought a professional receiver, an L-band, so 1987. And then, of course, these meteorological satellites began to become more and more sophisticated, more data. And so we, at Murdoch University, they had a special tower there built for environmental purposes. And we said, we've got the solution for you. And so we got their permission, and we put our dish, that dish is still there, X-band receiver, and installed in 2001, and was opened by Alana McTiernan. And I remember at the time we all had it set up, and we had all the displays, and as she was giving her speech, a wind gust came through and blew it all in on top of us, plus Alana. And anyway, again, this great series of satellites beginning, see, NOAA is the Meteorological Agency of America, AVHRR, stands interesting. Advanced Very High Resolution Radiometer, but its resolution was radiometric resolution. And its beauty was that it had thermal bands. So it wasn't just the optical, but it had the thermal. It took us right out into the region of the thermal, which then opened up a whole range of possibilities. And so, yeah, so, and then later that, the NOAA, they introduced this MODIS. Yeah, this is why we put that receiver in there. MODIS was a new sensor with 36 spectral bands, was put on 2 satellites. Terra had a morning overpass, Aqua afternoon overpass. The one on Terra has ceased to operate, because these satellites have to have their own fuel and rockets to keep on holding them out in orbit. But Terra on Aqua is still going. And then it's got a new sensor, what's called VIRS, Visible Infrared Imaging Radiometer Suite. And it's sitting on, NOAA 20. So we're in 20th of series. So the whole thing keeps on advancing. And so these Earth-observing satellites, these now this is, of course, Elon Musk has got his Skylink satellites up there. And but anyway, I mean, as the Earth is rotating, these satellites are going over, scanning the Earth, and collecting a whole stack of data, information. And of course, the secret is to how you extract that information and how you use it. So, one of your leading geographers, Gentili, He saw the potential in 79, saying that this was a scientific revolution, that being able to observe the Earth. So not only can we only see a very small part of the electromagnetic spectrum, we only ever see a very small part of the Earth, but you can now begin to see the whole of the Earth. And of course, two major sources of data we can get off that are important to us is the optical, particularly chlorophyll, where the green vegetation is growing on land, but also over the ocean, which is important. The ocean is 70% of the Earth is covered by ocean, and it's a very important carbon sink, as well as it absorbs 93% of the heat. Thermal data, evapotranspiration, fires and ocean currents. So we get to those, yeah. Now the sensors, when you want to use remote sensing data, you have to trade off and the resolutions, because you describe the data in terms of its spatial resolution, and everybody wants to see everything in as much detail as possible. Temporal resolution, how repeatedly you can observe that place on the Earth, and spectrally, what spectral information do you get? And so from a meteorological point of view, you want frequent recurrence. Yeah, for weather forecasting, you want to be able to update your forecasts daily. And environmental purposes, we can spin out. And so Landsat every 16 days, and of course of spatial resolution. Military, of course, they want to see as much detail as possible of where the Russians are putting their facilities. And then, of course, we're getting now what we call hyperspectral sensors that measure right across in many spectral bands, and I think one is about to be launched. So, NDVI. Now, you can now Landsat fly the whole of the metropolitan region plus Rottnest every year or every 2 years with a digital camera, which has 4 spectral bands, and it's stereoscopic, so you can get height, and we'll talk about that near the end. Landsat we have going every 16 days, and the meteorological satellite, AVHRR, okay, coarse resolution, but the data's coming every day and night, because as a satellite goes over, you have a daytime, and as it goes on the other side, you're getting a nighttime data. And so with thermal data, with things like fire, you can pick them up. And the more observations you get, the more you can detect fires. Now, often cloud is a problem, but if you have enough imagery, you can use what we call maximum value compositing technique, whereby you take a whole stack of pixel values and you select the maximum value, because if there's cloud, the NDVI will be very low, almost zero. And if there's no cloud, it'll be high. So you can create constant global coverage if you're wanting to track the NDVI over time, which is important if you want to follow what's happening in a growing season. There's many variants of the NDVI, and to try and get a more precise correlation between, say, crop yield and crop yield and the NDVI. Okay, so the main applications that were developed, and this was when I was involved, bushfire management became important, and is a major responsibility of government, particularly in remote areas, and where wildfires can break out at all times. And again, rangelands and grazing systems were important in agriculture. Sheep grazing on a paddock by paddock, and then of course 34% of West Australia are pastoral leases, and again the stocking rate, the number of sheep you carry becomes important, because if you overstock and you hit a drought, you rapidly degrade the country, and we'll come to that in a second. Cropping systems, yes, when we come to agriculture, there's been increasing movement towards cropping away from sheep, and of course then the opportunity of precision agriculture using marginal cost economics to relate your inputs to the yield potential. But there's also a forecasting potential that you can forecast regional yields, which is important for CBH to organize their receival of grain. Okay, two of the products that we developed that combine the model with satellite data, the state government, Department of Primary Industry Regional Development, Pastures from Space it's called, and you can go online and get it and use it. It's free, and it really helps to determine the stock carrying capacity of each individual paddock at a particular point in time, but it also predicts forward. And then of course we have pastoral remote sensing. There's another product that really works on the whole of the pastoral station as a unit for every pastoral station. And when you go into that product, you suddenly realize that we've got a lot of pastoral stations. Okay, and I discovered that a New South Wales company has commercialized it and is offering a product depending on how much you use for that price, and it uses freely available data. Sentinel is in fact the European counterpart to Landsat. Sentinel is run by the European community, and Landsat 8 is the NASA, the American, and they calculate a whole range of indices. And again, you can subscribe, and in putting together this lecture, I decided I had to try and learn, and so you go into the internet searching for what people are doing. Now, precision agriculture using the NDVI. Here the color coding. The reds are very low, the blues are very high yielding, and this is a sort of a typical image. We developed a product that was purchased by CSBP, and we called it AgImage, and CSBP wanted exclusive rights to it. No, nobody else can have it. And Summit wasn't allowed, but we sort of skirted around that. Governments, well, yes. And okay, this is some of the research we did to actually look at the correlation that you get between the NDVI and yield, final yield, and of course the maximum correlation is around anthesis. And you can predict anthesis in a crop using a simple heat sum, and then at that point you get the maximum correlation, and this is just some basic research I did so we could underpin that image. So now again, and you were talking, I think you mentioned to me, you're using handheld meters. Yeah, so for experimental purposes and even for student research projects, you can buy these handheld meters, and they use a word in remote sensing, what they call ground truthing. What you do from satellite, you want to, in fact, validate that it does correlate with what you see on the ground, or you want to develop a more tightly held model. Okay, handheld, and of course, all these companies are offering their products, and so there's a wide market sitting out there, and yes, I mean, Summit could make their own product. I'm surprised your name is not up there. But,
We use data farming imaging.
oh, do you? Okay, well, that's interesting. Oh, data farming, okay. Did you buy it or did you invest in it yourself? Some, yeah. Oh, no, well, I mean, this is absolutely great because now the interesting thing from my point of view is the next generation of students in ag science being trained in the use of these techniques, and therefore, able to exploit them in the commercial world or in the research world. Now, the other one, in fact, I first got into remote sensing using infrared thermometry to measure water stress. In fact, I was in Texas on sabbatical, and we were studying sorghum and how did it adapt to stress, and of course, temperature. Because plants survive, they reflect half the irradiance, because they're absorbing the red, they're reflecting the green and the other wavelengths. But they also evaporate water, which again cooling, and that's why in the leafy western suburbs, I tell people, look after your trees, because the bitumen can be 50 degrees, but the tree will pull the temperature down to about 20 degrees. It creates shadows, it evaporates water, and it creates what we call surface roughness. And so trees have a remarkable cooling effect on the environment. And, well, there are. This is, in 79, I had my son out there, and measuring, yes, so that's measuring the surface temperature, and the little spike out the front is a sensor measuring air temperature. And of course the NDVI and land surface temperature are negatively related. The more vegetation you have, the cooler the surface will be. And so yes, I mean, we're now looking where we've had a major drought, major tree death, and of course the thermal data would pick up where trees have died, and then Rottnest, where I work, and where most of the trees have gone, but you've got this sort of heath vegetation holding the sand together, but how much of that has died, I don't know. I mean, the thermal data would tell you as the rain comes through, that which is still alive, you will see it in the thermal data. Very, very useful data set, but it's much more complex to calculate evapotranspiration from thermal data, because you've got to have many more parameters. But again, it's an interesting area. Yeah, there is what's called a crop stress index, but again, it is more complex, more science is involved to calculate the parameters to calculate that index. So, okay, some of the major insights that came from applications of Earth-observing satellite data in WA. Now, this is an interesting one. Who's ever seen Western Australia free of cloud? This is almost free of cloud. It's August. You can see, yeah, because it's green in the southwest. There's a little bit of cloud sitting there over the Stirling Range. Somebody spotted this, yes, and they processed it, and in fact it was a sort of, yes, I've got it hanging on my wall, but the interesting thing about that image, as the satellite is on a descending overpass, was captured in 6.2 minutes as the satellite went over. The sensor, the MODIS sensor, was traveling at 27,000 kilometers an hour, and it was completing an orbit every 99 minutes. It was measuring reflected and emitted irradiance in 36 spectral bands. And it was broadcasting its data free to ground at 10 megabits per second. So you could put up your own receiving dish on top of your institute and you'd have all that data and you wouldn't know what to do with it. I know, yeah, I said you would learn, you train your students. But yes, well, at Murdoch University, that was Professor Tom Lyons. Okay, and the data was captured by a tracking antenna at Murdoch Uni. You have to, yes, and it's interesting because that satellite, the antenna would automatically lock onto the satellite and track it as it goes from horizon to horizon, because it's coming over the horizon and going, and then, yes. So it was well, 6 minutes. Yeah, that's right. You get 6 minutes while it's traveling over. Yeah. So the image, this actual image is created just using 3 of the 36 spectral bands, and it has been in fact combined with what we call a digital elevation model that has come off the shuttle radar to give you some sense of topography. The other interesting thing is the Landsat satellite goes over at 10:30 in the morning, not at midday when you have maximum irradiance. And the reason for that is shadowing, because unless you have shadows, you don't have a sense of perspective. Shadowless imagery is very hard to pick up a lot of features. And, but yes, well, you can go and get imagery, Google Earth. And if you want to look at Alcoa, how they are stripping our Jarrah forests to get, to create the aluminium cans so this is why Containers for Change, recycling, 10 cents. It requires only 5% of the energy to recycle aluminium than to start from scratch. And the environmental impacts of creating aluminium from scratch is quite significant, which is never in fact revealed. And of course, yes, you can see that, and I think further over you see the gold mine of Boddington. Yeah. So the other great part of the thermal imagery, and of course this is used by the Bureau because it's a part of their forecasting model, is in fact sea surface temperature. And there you can see one of the great features of Western Australia, which is why we have such a wonderful mild climate, is we have this warm current coming, the Leuven current. And of course it's driven by, in the equatorial region, the ocean is heating, it expands and flows downhill. But there is a cold countercurrent going back called the Capes current, which is nutrient rich, and where these two currents entrain each other, you get the phytoplankton blooms happening, and I'll show you an image later on. And but then is the beginning of the food chain. From my point of view, it's interesting. As a guide, I'm right out on West End and trying to explain, looking out over the Indian Ocean, and we're looking at the top of the food chain. We're looking at the osprey and the sheer waters, but the whales, the fur seals and so on. We see the top. But the phytoplankton are sitting at the base of the food chain. And of course, this is a very important part of the whole carbon cycle and the future of the Earth containing global warming. Okay, yes, and we pick up from time to time, we get these marine heat waves that can have devastating effects on the marine life. Okay, now this is an interesting one. When government released land for pastoral holdings, the Land Act mandated that you had to stock it and run sheep. And so what they did is people just put sheep, and the sheep multiplied, and on they went, and up they built till they reached maximum. Well, they reached, and then a major drought would come, and you would be grossly overstocked. And so when you look at that imagery, there's interesting. This is the Gascoyne River. It's in flood, and you see this massive sediment plume. And what you see is this very bright area. These are areas that have been overgrazed, and as you strip away the vegetation, the albedo goes up, becomes highly reflective, and of course, and now what's interesting when you look at the actual sheep numbers in the Gascoyne region, that you can see how it peaks. It peaks after 50 years, 1920, 30, it's peaking. Major drought, it collapses, and the sheep never recover. They recover back to a 50%, which is indicating that we have permanently degraded that rangeland area. And well, here's another recent image of that same region, where again the Gascoyne River, and you see a significant sediment plume. And of course you would see this of all the major river, the Fitzroy River, which should be interesting, which flows out near Derby. And of course, dust storms. I couldn't get a good satellite image of a dust storm. I could get the cyclone that caused it, and these. So, what's important? Soil. Soil takes a long time to form, and you can lose it within minutes. And in wet tropical areas, this is just sort of empirical data that I've sort of got off the internet, that to really take a these deep fertile soils. I remember the Liverpool Plains in New South Wales, you get these deep black soils, and they take many, many thousands of years to develop. But we can lose them just like that through poor management. The other thing was, yes, and of course we all know that, the Peel Harvey Inlet satellites, it's good for picking up algal blooms, because the algal blooms change the color of, and Peel Harvey at 1980, and of course the Dawesville cut was put in to solve that problem. And of course we get around, we get these eutrophic zones that we create with excessive neutron runoff. Yes, on the news last night, they were talking about the person who was growing mussels was concerned about the government putting in a desalination plant, because as you desalinate, all that nutrient-rich water gets dumped back into the ocean and would have undermined his livelihood. And of course, we've had this summer algal blooms appearing on the northern beaches, associated, well, we have our own desalination plants, and also wastewater that gets discharged will create these local algal blooms, which government doesn't like to talk about, because yes, for obvious reasons. Knowledge is power, so make sure you don't reveal too much. Yes, and you can see southwestern Australia, we are quite active in creating eutrophic zones. And of course, yes, you'd find them in the Swan River here. Yeah, and this is one that was reported 2016 in the Murray River. And yeah. Now, this is the interesting one. This was fascinating. And again, this was a PhD student who spotted that at the break of season, the clouds were forming over the native vegetation. This was, you can see the rabbit-proof fence there, the edge of the agricultural region, and you see it here, rabbit-proof. These clouds were forming, and then we actually, this is where Tom Lyons and some colleagues from Flinders University came. They brought their aircraft. We went, you fly there, you can see it. And so, what is happening? Well, what is happening is, yes, and you can see prior to the break, yeah, the agricultural area is highly reflective, high albedo. So the incoming irradiance is all being reflected back, whereas in the native vegetation, the vegetation is absorbing half the incoming irradiance, and that heat is then creating convection. And the convection is a necessary precursor to rainfall coming. And so you can see how we have, by overclearing, begun the whole process of desertification, which in fact we're living with now. And yes, yeah, so you can see the agriculture, the native vegetation, dark, and this is the analysis done by Department of Ag showing what's happened to the rainfall. The rainfall has moved inland. The rain has increased at Kalgoorlie, whereas it's been declining in the southwest, and it's continuing to decline. And I think it says 15% from when this analysis was done. But it's what we call a mesoscale effect. With global warming, there's a macro scale effect, which is pushing these fronts further south, so the rainfall's dropping over the Southern Ocean instead of over the land. But there's also, we've added our bit in there. We're an incredible species. I've never met, yes, when you think, we are the apex predator. And we've actually changed the axis of the Earth by the melting of the ice caps. I mean, yes, but yes, and all that data's there. All that data's there, revealing of what we're doing. And now the other thing that we did, we got some money. Farmers, the estimate of the area affected by salinity, based on census data, farmers estimated 2.5%. So we got money, and the project was known as Land Monitor. And we mapped it from satellite and concluded it was 5%. And what was interesting, having done that, we were told by government, you will never do that again. Why? People won't be able to sell their farms. It'll affect the real estate industry. But what survived was the mapping of the remnant native vegetation. And it continues as the Land Monitor project, and it's a part of NCAS, the National Carbon Accounting System, because that's a very important part of our national carbon accounts. And okay, well, we're switching now. We're going into the north, and here you can see, the satellite sensor is picking up fires in the tropical savannas. Savanna is a climax vegetation form which is a product of seasonal fire. And here you can see the fires, the smoke. So the satellite is picking up the smoke, but also the hotspot. There's two sets of data combined together, and hotspots. And of course, the government, one of the products that we developed and still is operational is what is called FireWatch. And you can see down here, you can get FireWatch, and they provide a whole set of associated data relating to fire. And in fact, that was one of the earliest demands from the Bushfire Brigade, DFIS, in remote areas where they had a fire. They knew there was a fire, but they didn't know where it was and how to manage it. And so they would ring us up in Perth, and we would manually go in and analyze the satellite data to find where the fire was, and then we would fax it back. And then finally, we worked out how to automate the process. And so it's a highly automated. But this is another interesting thing. This is in 1992. This was the perception of where fire, the major fire activity in the continent was. And of course it reflects where people lived. And so we in fact said, well, that's not what we're seeing from satellite. And we began, it's not only important to detect the hotspot, which is a thermal anomaly, but to actually map the burnt area, because you only can detect the hotspot as the satellite's going over, but it'll continue to burn. And so when we mapped the burnt area and the frequency, this was the fire regime. And we said, well, actually, the tropical savannas is where we're getting most of the fire activity, which was interesting, because then what was happening? Yes. Yes, this is DFIS. They basically took on board the use of satellite remote sensing, built their own training program and how you use all the different information coming off. And this is in fact their diagram of how they would train their field officers to use satellite imagery in the field. And now this is another interesting one. Coming from a conference in Darwin, somebody said to me, we have no stubble burning, we are practicing minimal tillage, stubble's incorporated. And I said, but that's not what the satellite's showing. That's showing that there's a lot of fire activity. And so we did actually go back into the field and ask farmers, what's happening? And it turned out, does anyone know the reason why this is happening? Somebody must know. The ryegrass has become resistant to Roundup, yes. And they found that the only way they could reduce the seed load was to get a hot stubble burn. In fact, yeah. So yes, I mean, it's, but it's interesting. I mean, again, this was just a chance. Yeah, it was just an interesting. And the other thing that we learned from mapping burnt area, that we could see that the actual area being burnt was increasing at 1 million hectares a year. You can see, in a sense, climate change coming, and we'll talk more about that. Climate change is changing the fire regime across the continent because it's changing the rainfall. And yeah, so one of the projects, and I think from my point of view the most satisfying, was this carbon farming, savanna burning, because what was happening in the north was, as Aboriginal people were leaving the land, going to European settlement, their traditional, and of course Aboriginal people, they really had only one technique to manage the vegetation, that was fire stick farming, and they were specialists at fire stick farming. And they used to use early dry season, they would start burning and create a mosaic to break up the fuel loads so fires couldn't spread. Now, as they left the land, the fire regime switched to the end of the dry season when you had maximum fuel load, maximum flammability, and as the monsoons built, the lightning strikes came, and away these fires would go. And we could track them on satellite. They would begin right over in the northeast, and they would burn and die down, and they would come, and they were going right across. And of course, the impact of fire is it knocks out the woody vegetation. It takes out the trees. And you're left with a grassland. Grassland is fire climax vegetation because the growing point is sitting below the surface. And so if you have frequent fire, you end up with prairies. You end up, and of course you will see within areas where Aboriginal people have been burning, they will actually create these little areas. When the Bussell family came north to Bustleton, they settled at a place called Cattle Chosen. The cattle obviously found an area that the Aboriginal people had established by burning, and that's where they settled. And so, talking to the Aboriginal people, we said, look, what's happening? They said, yeah, so the Aboriginal people, and that's where they've got this most marvelous saying. They summarize their cosmology by saying, the land owns us, we don't own the land, and they would care for the land. Now, what happened was, you can see then, we began to use Aboriginal burning, so we've classified the fires, those before July the 1st, and late season fires after July the 1st. Early season, late season, and the whole idea was to increase the amount of blue over the amount of red. And so that became the goal in the management of fire across tropical savannas. Now this is a third of Australia, tropical savannas. So what we were able to show with CSIRO, that by following Aboriginal burning, greenhouse gas emissions of carbon monoxide, nitrous oxide and methane were significantly less reduced. There's also a carbon capture component, because once you go back to the traditional burning, the woody vegetation will increase. The only problem is that we don't have a good way of being able to measure it, and that's where we're waiting on the university to come with a solution. Yes, and again, it needs a modeling approach to predict, but probably a better satellite sensors. It's low growth. Woody vegetation is hard to measure from satellite. It's easy to measure the tall stuff, but the others. Okay, so we were able to earn from government Australian carbon credits, get paid, and the social benefits was to create Indigenous employment, to get Aboriginal people back on the land, because when they go back on the land, they can also manage their sacred sites, because fire will damage sacred sites. Their rock art gets stripped away. So, Indigenous Ranger projects, and so since 2012, across northern Australia, there were approximately 76 of these burning projects, of which 70% were managed by Aboriginal Ranger groups. And the amount of carbon credits earned from government is over 100 million, and 70% Aboriginal. And so I would say this is probably the most significant outcome of the work I was involved with government here. So anyway, talking about now some of the future. Okay, what's important from a West Australian point of view is 92% of our land is Crown land. This is probably Crown land here, isn't it? But Crown land is land that's owned by the people, but held in trust and managed on our behalf by government. The question is, how well are they managing it? 34% is pastoral lease, 37% is unallocated, that's sort of going off into the Western Desert, 8% conservation, 10% reserves. Rottnest is a Class A reserve. It's owned, And now the interesting thing is, over these years, the amount of satellite data we've been receiving by government has gone from 1 gigabyte per day in 1999, and now currently in 2019, 16 gigabytes per day. And you can see the amount, vast amounts of data. There's no shortage of data. So for students who are interested, there's no shortage of data and there's no shortage of projects that students could pursue. Now this is due in late 2004. There's a new satellite called NISA, going up, and it's a collaboration between NASA and ISRO, the Indian Space Research Organization. It's designed to study the Earth's surface changes and to monitor, so it basically will give us a much more potent method of being able to measure woody vegetation, and will be a very useful, except we'll have to train people on how to process that data and analyze it. Okay, this is the problem we face. This is a challenge. Our emissions exceed, and the renewable sinks are important. So, and of course the oceans are critical, and that's a part of what is needed. Now, from satellite, this is an interesting satellite. What do you see? You see Rottnest, you see the land. You see here where they are dredging. This is where they're taking the shells to make cement. The cement we're standing on here would have come from these little shells, these little animals that extracted the calcium carbonate from the ocean, and we harvest them. But of course, you're looking at what happened. Rottnest becomes separated from the mainland 6,500 years ago, and you have these buried coastlines, you have these buried reef systems. But these reef systems are still important, as we have coral reefs forming on the south side of Rottnest, which is interesting. So, yeah, seashells are being dredged, and as they dredge them, they're also damaging the seagrass beds, which are also important carbon sinks. So, ocean color, chlorophyll A, phytoplankton. Again, from satellite imagery, you can get that. The last thing I just briefly wanted to talk about is what's called Urban Monitor. Landgate flies the agricultural area, the metropolitan area, and Rottnest every year, or sometimes 2 years, using a digital camera which has 4 spectral bands. It produces a whole stack of information, including height, and from that data you can see the vegetation, the urban tree cover, and of course it's being used by Department of Planning and Heritage to see, and this is Rottnest, and you can look at Rottnest where the cover is, and you can see, you can identify erosion zones area, and every year they plant out 34,000 species. They raise them, they plant them out, and they don't follow them up with any watering. I don't know how many die, and of course we have now the effect of the big drought that we've just had. What has been the death rate of the endemic tree species, the heathland species, where, why, and so on. So there's a whole set of questions there. And I've tried to access the data, but I've been told it's copyright. And I've approached the government agency, Conservation, Biodiversity and Attractions, and they say, everything that's to be known from that data, we know. So I haven't succeeded there. All I need is a PhD student, and I can gain access to the information under freedom of information, but I don't have the skill to process the data. Give me a student, PhD student. And okay, we can do all these things with these satellites: fire, grazing, flooding, water runoff, deforestation, revegetation, urban vegetation cover. You can even study how well we're doing with our solar PV panels. And again, I think the future is how we model carbon fixation. And my last dream, NASA has a wonderful website called Earth Systems Observatory. And they look globally at things that are happening, and they publish it and make it available to the public so they understand. I've often thought that in Western Australia, if we could get the government to do a similar thing, show us what's happening across the state. We don't know when we get all the major floods. Did we ever see who was impacted, where it was impacted, what the consequences were? No, a government holds this information tight to itself. And so I've thought about EO, a virtual Centre for Applications of Earth. where this information would be made public and the public could see what's happening across the state. That's my vision. Thank you.
Thank you. Look, I know some people have to go, but we'll take some, probably 3 questions, be brief. Yes, the first question here.
I'm going to challenge your statement. There's plenty of data out there, maybe in abundance. I come from agriculture, digging holes for 25 years. There is a dearth of reliable, geolocated data to integrate the satellite data to what is actually there.
Yeah, I would agree with you entirely. Yes, yes, I mean, there is no substitute for exactly what you do. Yes, and you need to integrate both. Yeah, I agree with you, yes.
Any other questions? Yeah, there's one here.
Going back nearly 40 years doing farm monitoring systems.
Oh, yeah.
First, the Land Management Society, Men of the Trees.
Oh, yes, yes.
But where we run into all the time, and one of the good selling points for adopting our methodology was it's good management,
Yeah.
it's a business plan.
Yes.
And all the farmers out there, they want to know how is it all going to affect their business model.
Yes, yeah,
More than anything else.
yeah,
So if you're going to plant trees, not just planting trees anywhere
Yeah.
for the sake of carbon, it's strategically so it improves
Yeah.
culture and for a whole lot of on-farm benefits.
yeah,
How do you get past that? Because at the moment we're still working in a market where the farm income is dependent on market demand, not environmental management.
yeah. Well, I think, seems to me the future is, yes, Australian carbon credits is ready to get government to, to commit. And I noticed the Department of Ag here have committed money to assist farmers to actually change land use to earn carbon credits. So there's potential, and I think the tools, yes, again, soil sampling. Yes, how do you measure the carbon being stored in the soil? Because that is really the long-term storage. And of course, you can't measure that from satellite. The satellites are not seen below ground. And it's really, and I think there is a research project going on. I don't know whether it's happening here.
The federal government is funded some rapid techniques and so on, but still the question is, not 0 to 30, but you have to go down, especially for the tree species. There's a lot of things going on at the moment, how rapidly you can measure so that we can monitor any so-called practices will lead to improved carbon sequestration. Not only that, he's talking about stored for a longer time, not what the smaller changes happening on the top layer. So good. Any other questions? Yeah. One here and then one there. Yeah.
Nathan Penny with the Department of Primary Industries and Regional Development. So one of those horrible people from state government. I've just recently moved sideways into a program which is working with a focus on rangelands, pastoralists and southern rangelands. And yes, there's been ever increasingly stations working with remote sensing, and there's some eastern operators, name drops, Seabar Labs amongst others probably, who are over here in WA providing services, integrating satellite systems with ground truthing. I guess what I'd like to ask you, with your long view of having been involved in this space for some time, what do you see as the future, short-term next steps with, say, in a pastoral Western Australian rangelands context? What can the industry do? What should they be trying to do? How should they be getting there? In 30 seconds, that'd be great.
Well, I think, first people like you are critical. that scientific expertise, because to be able to manage the stock, the grazing, because clearly grass, if it's not eaten, it's going to become fuel, and it'll burn up. And again, the woody vegetation, being able to encourage the growth. Yeah, because trees are the most efficient. I often think, and what is interesting is 10,000 years ago, as we are coming out of the last ice age and enter the Holocene, these were just barren sand dunes. And the pioneer species is the chert. And the brilliance of the chert is it would put its roots deep, deep down. Mm-hmm. It would bring up nutrients, put them on the surface, and you get the understory species. But it's that ability to store carbon. Mm. And of course, it's not only in the wood, but it's deep down. And so, yes, I mean, which we're beginning to appreciate now, the importance of trees. Trees, yes. I say, well, every day you should go and hug a tree.
But the question is, again, on the marginal lands, you talk about the tree growth is so slow, and it is going to take huge amount of time in actual sequestration storage. The last question from behind. Yeah, please.
Yeah.
Thank you. Fascinating in all respects. What's the sensitivity of the satellites now for things like critical minerals and being able to assess rare earth minerals, critical minerals, given the fact that they're below the surface? How effective is that sort of prospecting?
Well, the biggest challenge in West Australia is what's called the regolith. You've got this weathered zone, so looking traces, and yes, and this is what the so-called hyperspectral sensors, and of course in mining. Well, the first use of satellite imagery was really to assess the prospectivity, was to look for these alteration zones, and then you would zone in. And of course, there's a whole set of other airborne geophysical techniques that are widely used. And I think, the mining industry in many ways leads the way because they've got the money. Yeah, and I would think that there was a guy, Frank Honey, who in fact pioneered a lot of the early remote sensing in WA, and then he went and founded his own business, basically using hyperspectral data, but also using it to analyze soil cores. When you take out a soil core, you can use the same technique. Yes, remote sensing, it's interesting, remote sensing, you can take these same sensors and put them look out of space. So when you look at the James Webb telescope, the Hubble telescope, and it's interesting because my son, who did his PhD here in microelectronics, develops the sensors for shortwave infrared sensing. And a lot of potential.
Thank you.
Yeah.
So I think we will stop here, but I would like you to join Richard, thanking Richard for this wonderful lecture. In fact, he showed about 40 plus years of journey. I remember all the infrared thermometry. We're still using canopy differential temperature, the vapor pressure deficit, all the fundamental basis of the, if you like, the physics in relation to plant growth and development. But how that moved into the satellite imagery, and still there's a lot more can be done. I'm sure that application, what is happening with the CSPP and others, we would not have thought. Again, it starts from fundamental science and then going into applied area. There's a lot more unknown in that area. So let us thank Richard. Thank you. I hope some of the staff has gone because they have got other commitment. Potentially inviting Richard for some guest lectures in the Ag Tech program which we have. I will talk to Gustavo, who just left. He's leading that. Ken Flower used to teach into that unit. So we have a program in agriculture called Ag Tech, which is special. So they all start in ag science and so on, then they specialize in Ag Tech, which is about precision agriculture. And then we had Brian Buroff, who just left. He's the GIS man who is also there. So thank you once again, Richard.
Thank you for the opportunity.
Before I close, I just wanted to show that we
yeah.
have the next important event, which is the Can Australian Agriculture Achieve
Yeah.
Net Zero. Again, that's an important event. It's already fully committed, but you can register someone who is not going to come. We will just do that. And the Minister of Environment and Science is coming. Then we also have, this is just an important one, Dr. Ismail El-Aofi. We have not publicized this widely. She's going to come. She's the Executive Managing Director or Director General of a consultative group for international agriculture research, which is based in Washington, and this will be bigger than Ben-Hur. So she's going to come and look at the global agriculture, food security, and how this is going to shape up in the future. So please do note that date, and it will be the venue we will announce. So that will be around 5 p.m. on the August 8th.
Oh yeah, that should be good. Yes.
Then we have the Shenton Park Field Day Station open. Again, Minister for Agriculture is launching that. We have number of activities on that day, and that will be a whole day event from 9 a.m. to 3 p.m. We had the last one was about 3 years ago. So with that, I will close the event. Thanks again.
Yeah, thank you very much. Yes, yeah, that's good. Yes, a lot of action. Oh, that's good.
A lot of action, yes.
No, well,
I will
yeah.
stop this place. Yeah. Thanks again, Richard.
Oh, you're most welcome.
And it was good to see Wally Stern and all that. And, so.
Well, it made me think. I had to think. How was it? Did I get here?
I'll take this one off you. Thank you.